Hello guys, so we've been dealing with problems of TOSS-2. The first method is ILD. ILD, first, what is the meaning of ILD? And the full form is inference line diagram. So in the ILD diagram, we've been calculating first reaction, then shear force, and then bending moment. So as for reaction, you have to draw the same diagram, AB span of a moving load, something moving load W. So for the ILD of RA, the definition is maximum reaction at A, that is RA, will develop when the load is just right to the left, so will develop RA. So its height is 1.0. So vice versa, maximum reaction at B, that is RB, will develop when the load is just left to the right support and its height is 1.0. So this is the procedure for finding ILD of reaction. Then let's just solve a numerical problem on this. Numerical: a wheel load of 50 kN is crossing a bridge of span 12 meter. Calculate maximum support reaction. Given figure. First solution, that maximum support reaction, what we studied, that maximum support reaction at A will develop when the load is just right to the left support, that is RA max equals to, from that figure, say W is equals to 50. Same diagram you have to draw. For RA, maximum support reaction is just from right to the left and its height is 1.0. So we've been taking RA max equals to 50 into 1, that is 50 kN, and vice versa for RB, that is maximum support reaction at B will develop when the load is just left to the right support, that is RB left to the right support, that is RB1, and the load is 50. Then you have to place this load near this 50, and for that RA you have to place load this place 50 into 1, and RB for 50 into 1. Then you get RB max 50 into 1, that is 50 kN reaction. Now when you calculate 50 kN for that is single load. So you can calculate another numerical for multiple loads, that is 60 kN and 80 kN. Question given: two wheel load 60 and 80 kN is crossing a bridge of 18 meter. Calculate the maximum reaction at support. It is 60 kN, 80 kN with a distance of 4 meter. Overall distance 18 meter. Solution: same procedure for the calculation of RA. Maximum support reaction occur at A will develop when the load is just right to the left, that is RA max. Then for RB, same maximum support reaction, but the load is just left to the right for the RB max. So for the calculation, we have to draw a diagram of the ILD of reaction. So this is 60, 4 meter distance, and this is 80 kilonewton. Place the loads as it is that have been placed here. So 60, 80 at 4 meter distance, and the height is 1.0 for RA, and for RB same 60, 80 leading, in this 60 is leading. So we know the height of the 60, that is 1.0. For that 80, you just assuming y1. Overall length is 18, so this length is 4, so 18 minus 4, this is 14. And for this 60, 80 height is known 1, and 60 height is y2. For y2, same 18 minus 4, 14 meter. So for the calculation of y1 and y2, we have y1 or y2. So we've been using the formula base of smaller triangle by base of largest triangle into height of the triangle, height of the largest triangle. Yeah, so base of smaller triangle is 14 meters, smaller triangle base 14, largest triangle base is 18 meter, into height is always 1 for reaction. So y1 is equals to 14 by 18 into 1, you'll get some answer. Y2 is equals to same 14 by 18 into 1, you'll get some answer. And for the calculation of RA at maximum, 60 into 1 plus 80 into y1. 60 into 1 plus 80 into y1, you just get the answer here. substitute in kilonewton. For the RB max, same 80 into 1 and 60 into plus 60 into y2 plus 80 into 1. You will get some answer in kilonewton. Is for the calculation by if it is given two wheel loads.